So in this video, we're going to still talk about u-substitution, but one thing I mentioned last time is we're looking for a certain form of the integral. So we don't just need the derivative to appear on the main line of the integral. If a constant multiple of the derivative appears on the main line of the integral, then we can also do u-substitution. So it turns out to be basically the same idea, but let's say that we have something like this. We have 3x minus 4 quantity to the 7th dx, the integral dx. And what we want to do is we want to do u-substitution. So again, I have a function of a function, but I don't have any number other than 1 that appears on the main line of the integral. So I'm going to say that my inner function, which is u, is 3x minus 4. And then I'm going to say du dx is equal to 3. So in this case, what we have is we don't see a 3 on the main line of the integral, but we do have a 1 in there. And we can basically just say that 3 is a constant multiple of 1. So we can do u-substitution, but we're going to do it a little bit differently in this case. So what I would do in these cases is that I would solve for dx at this step right here. And I would say du is equal to 3 dx. And then I would say du over 3 is equal to dx. Okay, so here's what we can do now is if we go up to this integral, we can say that this is u to the 7th, and then dx is du over 3. And so I can take this over 3 and I can pull this out as a fraction in front. So I have 1 over 3 times the integral of u to the 7th du. All right, and then if I take the integral of u to the 7th du using the power rule for anti-differentiation, I get 1/8 u to the 8th. And we could put the plus c inside of the parentheses, but since we're going to multiply it by a third anyway, we'll just say that that's a new plus c. Just need one constant of integration. And so this is going to be 1 over 24 times u to the 8th plus c. And then I'm going to substitute back in for u, so I get 1/24th, 3x minus 4 to the 8th plus c. All right? And so here the idea is, again, we have a function of a function, and so we're going to substitute u in for the inner function. And we're going to see if we can find either the derivative of u with respect to x on the main line of the integral, or a constant multiple of that. So in the examples from the last video, we would always see that the actual du dx would appear. In this case, we see like a 1 we want to here, but the actual du dx is 3. So what we're going to do is, in this case, solve for dx once we get du dx, and then we can just plug in for dx in our integral, and then that tells us what the constant's going to be. Okay? So there are other cases like this that we could also look at. So let's say that we have something similar to what we did in the last video, but we have the integral of x e to the x squared dx. All right, so again, what we're going to do is we're going to say that we have a function of a function. So we have e to the something as our outer function, and then the inner function is the x squared and the exponent. And then we're going to look for the derivative of the inner function, which in this case is 2x, on the main line of the integral. But here what we see is we just see an x. So as long as it's a constant multiple of the derivative, we can still do u-substitution. So again, I'm going to say that u is equal to my inner function x squared, and then du dx is equal to 2x. And again, what I like to do is just solve for dx. So you have du equals 2x times dx. And then you have du over 2x is equal to dx. All right? So now what I can do up here is I can say that this is x times e to the u times du over 2x. And then this x cancels this x. So I pull the 1/2 out in front, and I have 1/2 e to the u du. And again, using the rule for anti-differentiation that says the integral of e to the x dx is e to the x plus c, we can say that integral of e to the u du is e to the u plus c. So I'll do 1/2 e to the u, and instead of multiplying the c by 1/2, I'll just make c be by itself. This 1/2 c would still be constant of integration. So then we can say that 1/2 e to the x squared plus c is our answer to the integral of x e to the x squared dx. So again, we have a case where the derivative itself doesn't appear on the main line of the integral, but a constant multiple of the derivative does appear on the main line of the integral. So you could do this in many ways, but this is a way that seems to be the most straightforward, is just solve for your dx when you do du dx. And then if you do that, you'll find that there's a constant that ends up getting pulled out that ends up multiplying what your answer would be if you had the actual derivative present. Okay, so hopefully this should take you through the quizzes that you have due this week.